Okay, hi everybody. We're talking about the required practical from the P2 chapter of your Caboodle book, which is about how to calculate specific heat capacity for a material, in this case a solid metal block. So this screen is taken from your Focus app, which you can access on your iPads, and you can see the apparatus here that you must know the name of. So we've got a heater which is sitting inside a metal block. We know the mass of the block, that is important, and the temperature is going to be measured using this thermometer. Notice that the metal block is insulated, and that is to prevent too much heat transfer to the surroundings. We want the heat from the heater to go into the block and raise its temperature. To supply the power and the energy needed to make the block hotter, we've got a power pack which we've set on 12 volts. That is making a current flow that we've recorded, and the immersion heater that's inside the block will be getting warmer. Now, very simply, if we want to calculate the specific heat capacity, let's say of aluminium, which we've chosen down here, then we can heat the block until we get a reasonable temperature rise, but we don't want the block to get too hot, because then the error caused by heat being transferred to the surroundings will be too great. So you can see here that I've heated the block for 2 minutes. It's gone from 20 to 26 degrees Celsius. Okay, and I could, if I wanted to, plot a point on the graph. Now with this information, I've got all the requirements to calculate the specific heat capacity for aluminium. Remember from the calculations videos, the equation, the energy transferred is mass multiplied by specific heat capacity multiplied by temperature change. So we've just measured the temperature change. We can calculate the amount of energy that's been supplied by multiplying 12 volts by 4.17 amps by 120 seconds. The time must be in seconds, and that would give us a value for the energy supplied. So we know the mass, and if we didn't, we could measure it on a balance. We know the energy supplied, and we know the temperature change, and all of those can be combined to calculate the specific heat capacity of this metal block. So you can see here that I've rearranged the equation so that I'm going to be finding the specific heat capacity. Remembering the unit of specific heat capacity is exactly what this calculation does here. It's joules per kilogram degrees Celsius. The unit of specific heat capacity, how many joules of energy for each kilogram to change temperature by 1 degree C. So from my calculation here, I will be doing the specific heat capacity. The energy is volts times amps times time in seconds. And that calculation will give me my energy supplied to the heater divided by 1 kilogram times 6 degrees C. If I do that maths on my calculator, I get an answer for the specific heat capacity of aluminium of just over 1000 joules per kilogram degrees C. Now that number is slightly higher than it should be, and that's because some of the energy from the heater has been transferred to the surroundings. The insulation isn't perfect, and I could improve my experiment by improving the insulation around the block.